Hello, Algebra 1. Welcome to the second set of notes on percents and proportions. In this part of the notes, we're going to look at converting units from one unit to another. We're going to use conversion factors, which are ratios that are used as multipliers. And then we're going to use a technique called dimensional or unit analysis. So in these notes, I have the common conversion table that we previewed in the first part of these notes. And so we've got three different areas for you. So we have conversions in length, weight, and capacity. So let's just jump right in and try our first problem. So it says, how many gallons are in 20 quarts? So if you look at your conversion table over in the capacity column, look for a comparison that has gallons and quarts. So our first comparison shows that there is 1 gallon in 4 quarts. So we can use that as a conversion factor. So the first thing you do in these problems is you're going to write down what you have. So we have 20 quarts. And then we're going to write that down as a ratio or a fraction. So we will write 20 quarts over 1. And that gets us ready to multiply by our conversion factor. So I'm going to use my multiplication dot, and then I'm going to figure out the conversion factor. Now what I have to figure out between my equivalency of 1 gallon to 4 quarts is that which will go in my numerator and which will go in my denominator. So I want, in my problem, when I multiply, I want my quarts to divide out. So I want my quarts to be in the denominator. So that means I want my gallons to be in the numerator. So I'm going to write this as times, and I'm going to put 1 gallon in my numerator over 4 quarts. So now what happens is that I am going to analyze my units. And so I notice that the quarts in my first numerator will divide out with the quarts in my second denominator. And then I can multiply my numbers straight across. So 20 times 1 is 20, and I have gallons. 1 times 4 is 4. So then I can divide out 20 divided by 4 is 5, and I'm left with gallons, which is what I want. So now I know that in 20 quarts there are 5 gallons. So that is how it works to use conversion factors and then that technique of unit analysis. So let's try the next one. How many fluid ounces are there in 3 quarts? So look at your table, and we're going to try to find a conversion factor for fluid ounces and quarts. Now if you look at the table, notice that the only comparison with ounces is to 1 cup. But then just above it, there's a comparison with cups to pints, and then finally with pints to quarts. So we're going to actually use 3 conversion factors in this problem. So the first thing we do, just like in the other, is we write what we have. So we have 3 quarts, and we're going to write that as a fraction or a ratio. Sorry, put that over 1. And then your multiplication dot. And now let's first start and let's convert our quarts, and in this case, to pints. So we want our quarts to divide out, so that's going to go in our denominator, and our pints to be in the numerator. So we'll put that times 2 pints over 1 quart. So that will convert to pints. So now our next conversion factor needs to take our pints to cups, because that's what we know. So we'll take it times, and we want our cups to show up, so 2 cups in the numerator over 1 pint. And then finally, we can convert our cups to fluid ounces. So we're going to take that times, and in our numerator, we will have our fluid ounces and put our cups in the denominator. So let's analyze the units. See how the quarts, the pints, and the cups will divide out. 1 in the numerator divides out with 1 in the denominator. And then if we multiply straight across, 3 times 2 times 2 times 8 will give us 96 fluid ounces. In the denominator, all we are left with is the number 1, and we don't need to write divided by 1 because that doesn't change the value of our answer at all. So 3 quarts will convert to 96 fluid ounces. Let's try the next problem. Including the end zones, a football field is 120 yards long. If you run the length of the field 4 times, how many miles will you have run? And our directions say to round to the nearest hundredth of a mile, or write as a reduced fraction. So we'll round to the hundredths place, I believe. The first thing we need to figure out is how long we're actually running. So let's take that 120 yards times 4. So we will be running 480 yards. Now look at your conversion factor table and let's figure out how we can convert yards to miles. So we have a factor that will convert miles to feet, and then we have one that can convert feet to yards. So let's use those two conversion factors. So 1 yard is equivalent to 3 feet, and 1 mile is equivalent to 5,280 feet. So we'll start by writing what we know, which is 480 yards, and we'll write that as a ratio, so we'll put it over 1. And then your multiplication dot times, and then the first conversion factor. So let's deal with the yards. Let's convert our yards to feet. So in the numerator, we'll have our feet, and then in the denominator, we'll have our yards, so that our yards will divide out. All right, now times, and let's convert our feet now to miles. So we'll have our miles in the numerator and our feet in the denominator, so our feet units will divide out. All right, analyzing, notice our yards divide out and the feet divide out, and we're left with miles. So if we multiply 480 times 3, we're left with 1,440 miles over 5,280. So we can divide that out, and then rounded to hundredths place, we get 27 hundredths of a mile. In our denominator, once we divide it out, it's just 1, and so we don't need to write that anymore. All right, let's try another. So an object is shot up in the air at 40 feet per second. This is actually a rate because it is comparing 2 units, feet per second. What is the rate in miles per hour? So we have 2 conversions to make. We need to go from feet to miles and then from seconds to hours. So look at your table, and we have a conversion that will take us from miles to feet. So let's just write that one down. We're going to use that one. Now, we don't have any time conversions in our table because we can use common sense for time. So we need to convert our seconds to hours. So we know that for each 60 seconds, there's 1 minute, and then for each 60 minutes, there is 1 hour. So we'll use these 3 conversions as conversion factors to do this problem. So let's start with writing what we know. We know 40 feet, and then over our seconds. And we're going to multiply that by, so let's start with our feet. Let's convert our feet to miles. So we want our miles in our numerator and our feet in the denominator, so our feet units will divide out. Okay, now let's work with our seconds. And so notice that we want to convert our seconds. First, we're going to have to convert to minutes. And so we want these to show up in the denominator. So we're actually going to put our seconds up top, so they will divide out, and then our 1 minute in the denominator. And then finally, we want our minutes to convert to hours. So we'll put our minutes up top, and then our hour in the denominator. So let's analyze those units and see how they will divide out. Our feet divide out. Notice our seconds in our first denominator will divide out with the seconds in the third numerator, and then our minutes in our third denominator divide out with those in the fourth numerator. And then we're left with miles in the numerator over hours, which is perfect. So if we multiply our numbers straight across, 40 times 60 times 60, we get 144,000 over 5,280 miles per hour. And then let's divide that down into a meaningful speed, which is 27 and 27 hundredths miles per hour. I hope you are starting to be able to see how you can use conversion factors to do these conversion problems. So what I'd like for you to do now is to pause the video, read through this independent practice problem, and work it on your own. And it's very similar to what we just did, except we're converting miles per hour now back to feet per second. So go ahead and pause the video now, and then I'll see you back in a moment to check your work. All right, welcome back. So let's look at this problem together. Miles per hour to feet per second. So writing down what we know 27 and 8/10 miles per hour. So let's start by converting our miles to feet. So we'll use that conversion, and our miles will be in the denominator so that it divides out, and our feet in the numerator. Now let's convert our time. So I've done something where I'm going to jump right from hours to seconds. So I know that there are 60 seconds in a minute and 60 minutes in an hour. So if I multiply those two together, I can get how many seconds there are in 1 hour, which is 3,600. And so now just analyzing those units, see how, well, first I multiplied. And then with the units, see how the miles divide out, the hours divide out, and we're left with feet per second. And now if you divide out your number values, we will get 40 and 77/100 feet per second. And that concludes the notes for the second part of the concept over percents and proportions.